Therefore, where's the other part of that pair? On,
The box.
not on the box. Somebody else said it?
Above the ground.
Up on the ground. If the ground's pulling down on the box is pulling up on the earth. So I draw my arrow up on the earth. All right, normal force. Normal force is what keeps objects from going through each other. So which way is the ground exerting a normal force on the box?
Down.
So if it's down, if the normal force is down here, that means that the ground is pulling the box down. You would have nothing opposing that.
The opposite side of each other.
Say it again.
The opposite sides of each other.
It would be. It would be up. Because the ground is keeping the box up. And where's the other part of that pair? On. Yeah. If you were walking on the beach and you look behind and you see your footprints, that's what's causing the footprints right there. Questions here? Just give you some little teaser about what's coming up next. We're about to do box on the ground. Yeah, that actually has an application that we'll get into. All right, let me show you the rookie mistakes. The things that I put up here, not as an example of what to do, but as an example of what not to do. Some of the mistakes I've seen in the past. People confusing receiver and source. You draw the arrows on what's receiving the force. The ground is pushing on the box, so I draw my arrow on the box. So one of the rookie mistake number one. In the videos, I might call number one something different. I haven't codified it yet. But rookie mistake number one today, this time, is drawing forces in the wrong direction. And let's go ahead and do it. The Mr. Yuck sticker. Don't do it. Rookie mistake number two. No man's land. I have seen this way too many times. Way too many times. I look at that and I'm going, all right, I'm not sure I can tell what force is acting on what object. Now, sometimes I'll see the boxes, they'll do the no man's land, but it'll be weight like that and weight like that. And I'm going, okay, that, or even if there's a small little gap there, you know, let's say normal force like this and then normal force like that. I have a pretty good idea of what the person intended. You might see me draw a line on a test just so that I can, this is what I'm claiming as these forces go with this go with that. But on this, I can't tell. So rookie mistake number two. Rookie mistake number three. Sorry. Part of my reaction is just flashing back. So, not separating the objects. Show that Y there. Give yourself room. If you need paper, got paper up here. But don't cram it all into a tiny little space. If you've done it in your notes, I hope you go back later and separate them. But all right, questions before we hit box on ground?
You said the first one is rookie mistake of force going in the same direction.
Oh, the first mistake?
Yeah.
The mistake here is drawing things opposite. Because all forces have a source and a receiver.
Mm-hmm.
So the source of this force right here is the ground. The ground is causing this. So the ground is pulling down on the object, so I draw the weight down on the object. But some students will draw the weight up on the box because they're thinking, or down on the earth because they're going, well, the ground's pulling down on the box, so we draw the arrow down on the earth. And that is wrong.
Gravity, gotcha.
All All right, box on ground. Draw the picture here. And because they're not the same box, I'm going to label one A and the other one B. If you prefer 1 and 2, go for it. What is the first thing I do for this force diagram?
Separate.
Anything we can get rid of?
Tension. Force.
They're all forces. Do you mean friction?
Or friction, yeah.
Yeah, why can't we get rid of friction?
There's no like movement of them.
Or desired movement? Yeah, because I didn't mention anything else. All right, we're left with the same two forces. There is a difference between this and the previous problem, but let's get down to I always find weight is the simplest. I recommend start with the easiest one and work from there. The easiest one, of course, is the one where your mind is at the moment you have to do it. So, but for me, weight is the simplest. So, weight is acting on what objects? What object? Which way?
Boxes?
A to B, B to A, and then pole is A, and then B to ground, and ground to B.
All right, so I would draw the arrow on what object in which direction?
A pointing down,
Draw on an arrow on A pointing down.
Wait.
and then I would do, I guess, B going up.
All right,
A.
that's a common mistake.
Okay.
That's a rookie mistake number 4. It's like you haven't done this before.
Never.
All right, here's the problem with this being the other part of that. This is making the claim that B is pulling down on A. Now, technically, yes, it is. But that is a path to madness, because the force between A and B is so incredibly tiny that you would need multi-million-dollar equipment to measure that. So we are ignoring those tiny little things because they are close enough to irrelevant.
So then ground up.
Yeah, it would be up on the ground. If this were the case, that means if B suddenly disappeared, A would just stay there. B is not the one who keep trying to make A fall down, it's the ground. So, yep. So up. And
B pointing down and ground pointing up.
now I've deliberately made a mistake here. The arrows are correct, the W's are correct, but there is a problem with this. So any questions before somebody tells me what the problem is? All right, what's the problem?
You didn't put an arrow pointing down from B. I mean, like,
Didn't put an arrow, what?
never mind.
It's supposed to be a yard down on the ground
From what?
from A, B, or from B.
From the normal force? Or a weight?
Wait,
If weight is down on the ground, that means that there's something pulling it downwards. Gravitational force is a pulling force. So, in order for that to happen, there'd have to be something on the other side of the planet. So that's not an issue here. What can you tell me about the weight of box A and box B?
A is smaller.
Say it again?
A is smaller.
A is smaller, not necessarily, but it could be. The big thing there is they're not the same. Or not necessarily. There's nothing in the problem to indicate whether the weight of A and weight of B are the same thing or not. You cannot assume that they are. So we need to somehow differentiate this W from that W. So rookie mistake number 5 we're up to, leaving off subscripts. Now the subscripts I like to use are the ones associated with the object, so I would label this W sub A. Some people will have all the pairs and they'll just start on the left side and work their way right and just start with 1, then 2, then 3, and so on. As long as you differentiate them correctly, differentiate them properly. So if that's WA, this would be WA, this would be WB, and that's WB. That's supposed to be a P there. So we need to, if you have multiple of the same type of force, you do need to have subscripts, unless you're saying that they are equal to each other. I am saying that that magnitude and that magnitude are equal. They're part of the same pair. And this are equal, but A and B, without more information, cannot make that assumption. Now, if you bring in the generalized gravitational force, as Yvette was sort of indicating, then the reason that's a path to madness is if I have a force between A and B, gravitational force between A and B, then perhaps I should also include between the top half of B and the bottom half of B. Or maybe the right half and the left half, or the upper right quadrant and the lower right quadrant. And I mean, you eventually, every molecule, every atom would have forces involved, and we kind of stop somewhere. All right, normal force. We haven't done that one yet. We've done finished weight. Normal forces.
A and B.
Which way on A, which way on B?
Away from each other?
Yep. So that would mean up on A. Let's see. So YA, YA. They're touching each other. A would be falling if B disappeared, so there's B's gotta be holding it up. And anything else touching? And the ground's holding B up. And B is pushing down on the ground.
Would it be wrong to do another diagram to separate the two different forces?
I would not recommend it because ultimately where this would lead in certain physics classes